Hey guys, Mr. Crofton back here. I want to give a quick shout out to Section 7. We just got done just an amazing lesson on exactly what we're talking about today in this video. We're talking about the area of sectors and the length of arcs having a lot to do with circles today. So, when thinking about area of a sector, length of an arc, you want to think about pizza. That's how we learned it. That's how we're going to build off of it. So, the area of a sector is like the area of a slice of pizza. So if I wanted to find out how much pizza I'm eating if I eat that whole blue slice, that's the area of a sector. The arc length is basically, you can picture it as a piece of crust. If I took that crust off and laid it out flat, how long is that crust? So this is a portion of the area and a portion of the circumference. So for us to move forward, you gotta know, and you should probably have it down pretty good. The area formula for a circle is pi r squared. Okay, and you remember that squared for area because when you measure area, you always do it in units squared. And circumference of your circle is 2 pi r. All right, 2 times pi times the radius, or you could represent it with pi d. That's pi times diameter. That's the same exact thing. So those two things we got to have committed to memory. You should be really good at knocking those out in your calculator really quick. All right, going through, first one we want to find is the length of an arc. So arc length is a portion of the distance around the circle. It's a portion of the circumference. It is this length from C to D, if I laid that flat and measured it. And here's the kind of setup we want to use. We say the length of the arc is our x. So it's x over our total circumference. And I know, I don't want to do these every time, but a little side problem, circumference is 2 pi r. So our circumference here is 2 times pi times the radius, which is 7, which I can simplify just to 14 pi. So I'm going to leave that at the bottom of my fraction. Okay, so that's my circumference. Notice you could do that in decimal form right now, and it would be something around in the 40s. But I'm going to leave it in terms of pi just for simplicity now. Measure of the arc then is this degree. It's the portion of the circle you want, which is 20 in this case, always out of 360, because I want basically 20 degrees out of the 360 of the circle. Then we've got a fraction equals a fraction. We always cross multiply. So I'm going to get 360x equals 20 times 14 pi. I'm going to throw that right in my calculator, and I'd get 879.646. Cool. Now that I've cross multiplied, I've got a really easy last step. I divide by 360 on both sides of my equation, and I'm left with x equals 2.443. And don't forget a unit here is centimeters, just because it's a length, arc length. Very cool. Let's try another. Now we've got the area of a sector. Notice the formula I've got set up here, and before we do that, no, the sector area is a region bound by 2 radii and the arc of a circle. It's the area between this arc and 2 radii. The area in there. And the formula, the setup we have is very, very similar to the length of an arc. Area of a sector is always our x. That's what we want to find. So I set up x on the top over area of a circle. I'm going to, again, do this one really quick on the side. Area equals pi r squared. So area equals pi times 5 squared, or 25 pi. Notice again, I could take that area and put it into decimal form. In other words, multiply 25 times pi. You'd get 78.5, something like that. But I like 25 pi just because I don't have to deal with decimals. You know, that 78.5 something is a long decimal. I'm going to avoid that until I really, want to get into that. Anyways, area of a sector over the area of a circle equals measure of the arc, so the portion of the circle that you want. In this case, it's 140 degrees, always, again, over 360. Notice, very similar to what we just did, right? Cross multiply. 360x equals 140 times 25 pi. I could, at this point, leave it in terms of pi, or I could multiply it out and get the decimal. I'll get the decimal just because why not? 10,995.574. Yikes. I know that's an ugly number. It's a big number. There's a lot going on. But once I divide by 360, I'm going to make it at least smaller and not as crazy. And I get x is 30.543. And this is the area, so it's in inches squared. Cool. Those are our two most basic problems you're going to see. That's a skill you definitely want to get down. So next one, we're looking at something a little funkier looking. This is called the annulus, aka the donut. You want to find the shaded blue region here. And it's going to be a lot easier than you think. All right? I want to find the shaded blue region. So the first thing I want to do is I want to find the big area of the large circle. Right? It's got a radius of 27. So the area of the big is pi 27 squared, which is equal to 729 pi. I'm going to leave it in terms of pi because I know it's an even number with pi, and why not keep it somewhat simple. Area of the small now is the second thing I got to find. Area of the small circle is this guy right here, which has a radius of 20. So area of that is pi 20 squared, or 400 pi. Now, to find my annulus, I subtract the two, right? You find the big area, you take out the small area inside. So it's 729 pi minus 400 pi, and I get left with my final answer that I'm going to leave in terms of pi, 329 pi. No units given to me, so I'm just going to say units squared. And you can multiply that out and you get something around 1,000, but leaving it in terms of pi is generally acceptable as well. Okay, one a little trickier now. We're combining the past two problems we've done. First thing I want to do is, I see it as being easiest if I picture this annulus being completed as one whole donut. Right? Imagine that part is all filled in. If that part's all filled in, all I have to do is a quick annulus calculation. So my big radius is 10. So the area of the big is pi 10 squared equals 100 pi. Small. Now my radius is just 8 in the small circle. So area of the small is pi 8 squared, or 64 pi. To find my annulus, two ends, I'm going to subtract them. 100 pi minus 64 pi, and I get left with 36 pi. But don't stop and say I'm done there, because remember, that's for the whole annulus if this was continued all the way around the circle and all this area was included. But I only want 120 degrees of it. So I take that 36 pi, and I gotta think, what portion of a circle is that? Well, you got two options. One, you could go back and set up a proportion just like we did with our sector. Area of the sector equals the area I found, which would be our 36 pi, equals measure of the arc over 360. Or, let's do it easier and realize 120 out of 360 is equal to 1/3. Hey, that's a good thing to know. Multiply that by 1/3, and I get 12 pi centimeters squared. That's my final answer. Look at that. That's a nice, quick little shortcut for you. Keep in mind, whenever you're doing these, you can always just use that fraction multiplied by the total, and you will get your answer. All right. I got some complaints that the joke wasn't good enough last time, so I'm trying to make up for it here. First part, squares and triangles agree, circles are pointless, but hey, you got to be nice to the circle. He's a nice guy. He didn't do anything wrong, so let's get a positive one in there, too. Lovely triangle says, why are circles so hot? Because they're 360 degrees. Oh, that's a good one. Look at that. That is a relatively high temperature. I agree. Jim the circle, circles come in all shapes and sizes. Well, all sizes at least. He got his large circumference from eating too much pie. That's a good one, pie. And the last one, the roundest knight at Sir Arthur's table was circumference. He gained weight by eating too much pie again. Oh, so punny, so punny. All right, our last one here, and then I'm going to leave you with a little challenge to finish it, okay? So, given the diameter of a small circle is 6 centimeters, what's the area of the shaded region? You look at this, you think, oh my gosh, how do I find all those little areas? It's okay. You know this is 6. All right. So first goal, I would say, if each circle is the same, find the area of 1, and then multiply by the number there are. The radius then would be 3. So I'm going to do pi 3 squared equals 9 pi. Good, I like that much. How many are there? 1, 2, 3, 4, 5, 6, 7. So I multiply it by 7. Uh-oh, we got kids coming in. 56 pi is that unshaded area. Let's find the shaded area. If this is 6, and this is 6, and this is 6, then the whole line would be 18, and that's the diameter of my big circle. So let's go find the area of my big circle. The diameter is 18, my radius is going to be 9. So pi 9 squared equals 81 pi. Take these two things. I want to take the big circle, which is 81 pi, and subtract out all of these little cutouts, basically, right? I'm taking a cookie cutter and I'm cutting this out every single time. I subtract my 56 pi, and I am left with 25 pi centimeters squared. So a lot of these problems is about finding little tricks. All right, last thing I'm going to leave you with here, a challenge. Rank these shaded areas from the largest to the smallest, okay? So A, B, and C. Tell me which is largest and which is smallest. And my hint to you, well, not my hint, my answer, they're all the same. But the additional challenge, first, prove that they're all the same. And second, what about D, and I'm telling you it's not the same. My hint to you will be, this is 8 centimeters, meaning this part is also the diameter, which is 8 centimeters. All right, guys, I'm going to leave you with that challenge. Try to figure out how that shaded area relates to these shaded areas. Well done today. Great work. Have a good one. Bye-bye.